How far do you agree with the Big Bang Theory? Is it even possible for us to predict how the universe would have started, provided that billions of years ago all physical laws could have been entirely different from the present ones? One question of mine would be that, is there anything in the universe having speed of more than light? Let's concentrate on the Big Bang. One question per person. So, how far do I agree with the Big Bang Theory? It's not whether I agree or not. It makes sense. See, in science, in mathematics, in physics, you don't believe things. There is no belief. There's no I agree with this or I don't agree with this. This is not politics. It's not about opinions. It's about data. It's about facts. It's about evidence. So let's talk about the Big Bang Theory. How did physicists come up with the Big Bang Theory? It's not so that somebody. It's not like somebody dreamt it up and everybody said, "Okay, let's agree to this." It's not about consensus. How did this happen? So, in the 1920s, Edwin Hubble uh, came up with what's known as what he discovered. What Edwin Hubble discovered is that all galaxies are moving away from us. Okay, so he did a lot of meticulous calculations about, and how did he find out that galaxies are receding away from us? Because these galaxies are redshifted. When something goes further away because of the relativistic Doppler effect, the light that comes from that object is stretched out. When it's stretched out, it is shifted towards the red end of the spectrum. So there are certain elements that give off very characteristic wavelengths. You know what they are. When you look for that, you will find that it is shifted towards the red end of the spectrum. And the more it is shifted, the further away that thing is going away from us. And the further the speed is, the velocity is. So not only are galaxies and other distant objects going away from us, they are the movement is accelerating, which tells you that the universe itself is expanding. That is why the galaxies are receding further and further away from us. And the further you go, the faster they are moving away from us. Right? So Edwin Hubble came up with a certain value for what we now call the Hubble constant. Today we know it's about 70, roughly 70 kilometers per second per megaparsec. Whoa, that is the value. So the first piece of the evidence is that the universe is expanding. There is unambiguous, incontrovertible evidence from observational evidence, from observations, that the universe is expanding. Distant objects are moving away from us, and the more distant a galaxy or object is, the faster it is receding from us. So the universe is expanding, and the expansion is accelerating the further you go away. So now, let's say you reverse the time. If it is expanding away from us, in the past, those objects would have been much closer to us. And based on the speed of the expansion and all those things, if you do proper detailed calculations, you will find that if you go back about 13.7, 13.8 billion years before today, the entire universe would have been compressed into a single point. Right? It's clear. You just have to take the expansion backwards in time, and you can come up with the approximate time when the universe was born. Right? So that is one thing. There is no doubt about the fact that the universe is expanding, and the expansion is accelerating. Secondly, so it was clear that the universe would have started as a single point, or something very close to a point. Then uh, then people understood that if everything was concentrated into a point, it would have been just pure energy, incredibly dense energy, right? And then the expansion happened, which Fred Hoyle called the Big Bang. So if such an event happened, there would have been an immense amount of radiation in the past. And as the universe expanded and cooled, that primordial radiation also would have cooled down and stretched out over time. It would also have been redshifted over time. Very clear. And if that happened, then that radiation would still be present in the universe today. And if you know how to detect it at the appropriate wavelengths, you should be able to find it. So until the 1950s or so, people did not quite agree with this theory, this Big Bang theory. They said it is like creationism. The Christian creation doctrine that God created the universe and all that. So they said that the universe should be a steady state universe. There is no God in all in science, and you're trying to recreate Christian theology and so on. The Christian theology says that the universe was born about 4,000 years ago. In physical cosmology, the calculations were about 13, uh, came to an answer of about 13 point something billion years, or whatever the initial calculations were. So most physicists at that time did not believe in this ridiculous idea of a big bang. Fred Hoyle even gave it the name Big Bang just to make fun of it, but that caught on in the media. So that's why it's called the Big Bang theory. It's not a bang, it's not an explosion, it's an expansion. But then what happened is that this cosmic microwave background radiation was discovered by Penzias and Wilson, I think. I think. So they discovered this relic radiation, the leftover radiation that can only have come from this Big Bang event. And over time, we have mapped this radiation out. It's very, very uniform, but over very large scales, you find anisotropies and fluctuations in the levels and all that, right? So you have the Planck satellite, then the WMAP satellite, which has given us a very detailed map of the background, the relic radiation of the universe, and so on. So because we have the evidence of the expansion of the universe, the accelerating expansion of the universe, and because we have this telltale clue uh, of the microwave background radiation, the CMBR, these and we have lots of other data points that I will not go into. Because of all these data points, it is clear that this event actually happened. So it's not about belief. Nobody believed it until they found the evidence. You get it? Science is not about belief. It's not about agreeing with this or agreeing with that. You look at the evidence, you use the tools of science, the scientific method, and if the evidence agrees with the theory, then the theory is likely to be correct. Even today, the so-called Big Bang theory is not perfect. It doesn't explain why this happened. It is only a chronological history of the universe. What the Big Bang theory, the Big Bang model, the lambda CDM cosmological model, what it does is it attempts to recreate the chronology, the chronological history of the universe. It is unable to explain why things happened. What caused the Big Bang? We still don't have the answer. We are trying to figure it out. And there are lots of uncertainties. The very initial moments after the Big Bang, we don't know anything about it, more or less. Yeah. The inflationary epoch, the reheating epoch, we have recreated much of it based on observational evidence. So I am very clear about this. All scientists, physicists, cosmologists are clear about this. The best theory that we have today about the origin, about the history of the universe, is what we call the Big Bang theory, right? So based on all of these things, we can actually uncover roughly what happened and possibly predict what will happen in the future, right? So that's how it is.